tonight I'm going to talk about 4 planets: Mercury, Mars, Earth, and Venus. Look out for the Martians. That's Mars. How do you know?
Because it kind of looks like Earth.
And what colour is it? Kind of red? Kind of red brown?
Have you ever seen the shirt?
Yeah, fill it up.
Okay, Mike, I'd say that.
One spot.
This doesn't want to work. Well, you have a laser pointer, but that's, yeah. Well, it was on. Yeah, power's on, just doesn't want to advance.
Well, that's frustrating.
Well, let's use this. Oh, is this just not, does this not have focus, and that's why? Oh, there we go. Okay, so it's working. Just had to click into it. That's back, that's forward.
Okay.
There.
Like you want lights on.
Red lights, please. So shall we start?
Yeah.
Well, good evening, everyone, and thank you for coming out on this horrible evening. But be grateful it's a water falling from the sky. Be thankful you don't live on Venus. You'll find out what I mean later on. But this weather for me, it makes me feel quite nostalgic. It's like a summer's day back in Scotland. Right, tonight I'm going to talk about the inner planets, the 4 inner planets. It's part of an overall program we intend to run over the next year or two, covering all the fundamentals of astronomy. That you see, we did a 101 a month or 2 ago on the history of astronomy, the sun and the moon. Now we're on to the inner planets. There are, of course, 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. 8 planets. And this shows you how far apart they all are. And if you look here, this bit, where are we? There we go. You can't actually see this. I'll do my finger. This bit here is squeezed in that area there. The inner planets are very close together, and the graduate spreads way, way out to the outer solar system. That number AU, astronomical unit, is the distance of the Earth from the Sun. So Uranus is over 19 times as far from the Sun as Earth. The first 4 planets, like I said, are the inner planets. The other 4 are the outer planets. 2 of them are gas giants and 2 are ice giants. Now, there used to be 9 planets. When I grew up there were 9 planets. But in 2006 they decided that little Pluto no longer qualified to be a planet. To be a planet now you have to be in orbit around the Sun. You have to be big enough, you form a round shape, and you have to have cleared the entire area around you. It's because when they found Pluto, they thought Pluto was the only one out there, far out. They've since found more small planets out there in what's called the Kuiper Belt. So Pluto's now been demoted, is now classed as a dwarf planet. Poor wee thing. The inner planets, like I said, Mercury, Venus, Earth, and Mars. There's the comparative sizes. Mercury here, Venus, Earth, and Mars. The Venus and Earth are almost like twin planets in size and basic structure, but you'll see later on there's some really big differences. Mercury, the planet closest to the Sun. It has the shortest year, but the longest day. Because it's so close to the Sun, it gets incredibly hot on the sunny side, but beyond freezingly cold on the side away from the Sun. And it's named for the Roman god Mercury, the messenger of the gods. As I say, it's the smallest planet in the solar system. It goes around a very eccentric egg-shaped orbit. It goes around the Sun every 88 days and rotates every 59 days. and it has no moons. That's Mercury inside, racing around that yellow circle. You see Earth is one in the blue ring. You see the difference in speed? Now, like I say, Mercury goes around the Sun every 88 days, but it rotates every 59 days. That's very different. It's one of the things I like people to pick up tonight. How things change in astronomy over the years. Learning changes. When I was a boy, when I was your age, Mercury had a year of 88 days and a day of 88 days. We believed that it went around the Sun at the same time it took to rotate, just like the Moon goes around the Earth, so that one face of Mercury would always face the Sun. That's what was thought back then, until we managed to get a space probe down there and see it actually goes round faster than it orbits. I was saying to my colleagues earlier on, Mercury used to have an 88-day rotation day, but I don't know when it changed. I had when they switched it on, going around faster. But as I say, new research could overturn old findings. Because it's so close, the side facing the Sun, 800 degrees, about twice the heat of your oven on the surface. The other side, minus 290 degrees. There's no atmosphere to keep the heat in, to transmit the heat. So one side is incredibly hot, the other side gets incredibly cold. As you've seen from the earlier pictures, it looks a bit like the Moon, covered in craters and hills and stuff. No atmosphere to protect it from the things falling on it. Very, very dry, very barren. There's a new probe gone up recently, Bepi Colombo, from the European Space Agency and the Japanese agency. It's going to go into orbit around Mercury. It's already approaching. And that's one of the latest pictures we have that it took in passing, getting settled down into its orbit. It's a very powerful magnetic field, which is good for Mercury, because if there's anyone living there, that is, because it deflects the solar wind from the Sun. When I get to Earth, I'll explain why, but that's important to protect your atmosphere if you had one. They've confirmed the presence of water ice at the poles, even though the side facing the Sun gets so hot. At the top and bottom of Mercury, at the poles, the craters are in permanent shadow, so the water ice is collected there. It doesn't melt, because there's an atmosphere to conduct the heat from the Sun to make the water melt. And I indebted to one of my colleagues here when I was putting the presentation together. I did not know this a month ago, that Mercury has a tail. That the solar wind and the heat of the Sun blast some atoms off the surface of Mercury away from the Sun, and the Sun's rays light it up and give you a very, very faint tail, just like a comet. So in some ways Mercury is a very large captured comet. On to Venus, the second planet from the Sun. Beautiful grey Venus. This is the morning star. This is the evening star, depending on what time of day you see it. It looks very, very nice. It's our twin planet, same kind of structure, same kind of size. And Venus is named for the Roman goddess of love. Except, below the clouds, Venus is a vision of hell. It's a really, well, you'll see, not a nice place. Second planet from the Sun, same size as the Earth. The trouble, Venus's problem, it's got a very thick atmosphere. I'll answer your question at the end, okay? It's got a very, very thick atmosphere, and that traps the heat. You heard people talk about the greenhouse effect potentially affecting Earth. Venus has a runaway greenhouse effect, and the heat doesn't get out at all. With radar, they've been able to scan the surface, and you can see the bright parts, the yellow and orange, are the highlands, and the blues are the lowlands. So it's got an uneven surface. It takes 225 days to go around the Sun. Earth days to go around the Sun. Its day is 243 days. So on Venus, actually, its day is longer than its year because it rotates so slowly, and it spins backwards compared to Earth. The Earth goes towards the east to the rising sun. On Venus, you go to the west to the rising sun. I'll let you absorb that for a second. What that's trying to show you, if you look at the little arrows coming out of Venus, show how it rotates going the opposite way. Now, I mentioned about the rain here. On Venus, the clouds are made of a sulfuric acid. The pressure on the surface of Venus is 90 times the pressure on the surface of Earth. Anybody here from the Navy? No? If you know about submarines, modern submarines go down to about 2,000 feet underwater. The pressure on the surface, the atmosphere pressure on the surface of Venus is like 3,000 feet underwater in the ocean on Earth. It's incredibly hard. Yeah, it's not a nice place. If you could see under the clouds, we think it would look like that. But very, very dense, very, very hot, with acid rain falling. This is a slightly complicated slide, but the important thing I want to look at here is round about here. Well, on the surface, the pressure is 90 times the pressure of Earth's atmosphere. Up about 50 kilometers above the surface, the pressure is about the same as Earth's atmosphere. We'll come back to that. And the temperature is about the same as Earth as well, so there could be potential for microbes to live in that level of the atmosphere. And some groups are putting together probes to go and look at that level of the atmosphere. Back in 1985, the Russians did it the first time. They put a balloon in the atmosphere, and it lasted for about 48 hours, drifting around at that level. And now I know MIT and JPL are looking at new balloons to go to Venus to drift around. Because if you go to the surface, again, those horrible conditions. The longest lasting space probe to Venus lasted about 2 hours. It landed on the surface and lasted 2 hours before the pressure and the heat and the acid got to it. Because basically, we all know about the rovers like Perseverance on Mars. The Perseverance rover weighs about a ton. To put a rover on Venus that could cope with these conditions, you need something the size of a tank. And they weigh about 50, 60 tons. And you ain't fire one of those up in a rocket there anytime soon. Do you have a question?
Does Venus have the most volcanoes?
Venus probably does. You're right. I hadn't thought of that. I'll have to check that.
What was the question?
Does Venus have the most volcanoes? And
He said a lot of like astrology videos, so he
Yeah.
really
oh yeah, sulfuric acid clouds. Like I said, be glad it's water falling up the sky here. The Venera 13, in its 2-hour life on the surface, got us this picture from the surface of Venus. But as I say, Venus, they tried to go there, and it's very hard to make things survive. Personally, I think the way ahead is to send up balloons that can drift around at that 50-kilometer height to check the atmosphere there. Earth. Anybody heard of this place?
Yes, this is where we live.
Right. But it's unique and it's very fragile. We're the third planet from the Sun, 93 million miles from the Sun, which is 1 astronomical unit. How long is a day?
24 hours.
How long is a year?
365 days.
Good man. I don't have to do the talk anymore. We've got one moon. What's it called? The moon. It was a trick question. We have one moon, it's called the moon. But the moon is so big compared to the Earth. Other planets and moons, the moons are much smaller than the planet. But in our case, this could be almost a double planet because our moon is so big. A lot of facts here for you to consider. Very hard rocky core of the Earth. A lot of hot fluid stuff around it coming up to the mantle and the crust. The crust where we live is only about 20 miles thick. Very hot under there. We live in the cold bit on top. plate tectonics. Again, a bit of personal history. I remember when I was at primary school in Scotland, looking at a map of the Earth, and you could see Africa and South America. I said to my teacher, "It looks like South America could fit into Africa." Don't be silly, boy. Continents don't move. Before they discovered the theory of plate tectonics, the continents do move around. You see where we are over here on this plate? I'm from that plate over there. Over here you've got the Indian plate crashing into the Asian plate, creating the Himalayas. And these are moving all the time. We have a magnetic field driven by those fluids under the surface. And that's very important because if we didn't have the magnetic fields, the solar wind, these charged particles coming from the sun, would drive away our atmosphere. We'd have nothing to breathe. You see here the solar wind coming from the sun on your right, on your left, my right, hits the magnetic field, and the magnetic field deflects it. It's our deflector shield that protects us from the solar wind. Again, you probably know this, 70% of the Earth is covered in water. We could, seen from a distance, we look like an ocean planet. The air, mainly nitrogen, oxygen, and it protects us as well from meteors and meteoroids and things falling from the sun, from the sky. But this is one thing that always got me. If you imagine the Earth was the size of an apple, our atmosphere is as thick as the skin. We're in a very, very, very thin layer where you can live on the Earth, the biosphere. We live down there. You go up here, you can't breathe. Now you all know this, we're the only body known to support life. Why? Well, Earth has the right chemical ingredients, we're in the habitable zone where you can have water, we've got the right temperature from the sun, we've got the atmosphere to keep us warm, we've got the magnetic field to protect us from the solar wind, and the plate tectonics and the ocean tides move the materials around to keep refreshing the raw materials for life. Having a moon as well, the right size and place, moving the tides around, also helps recirculate all the materials. What are the chances of life developing on another planet like this of our size? Well, remember, life actually developed on Earth 5 times. There have been 5 mass extinction events where almost everything died out, and life came back because the conditions were right. The extinction of the death of the dinosaurs was only the latest of the mass extinction events. Every time life came back, so with the right conditions, life will develop. The chances of life developing on other planets elsewhere, well, look at the size of the universe, look at the size of our galaxy. Up to 400 billion stars, up to 100 billion galaxies in the universe. So perhaps, you never know. You can play the theme tune in your head. This was an amazing photograph when it came back in 1968 when Apollo 8 flew around the moon and came around and they saw Earth rising over the moon's horizon. The first time people had seen this, that gives you a real perspective of how small and fragile our planet is. And if that isn't enough, can you see the Earth there?
It's so small.
That's about almost 4 billion miles away from the Voyager spacecraft leaving the solar system. The famous astronomer Carl Sagan got them to turn the spacecraft round and point the cameras back at the Earth. You can just see that pale blue dot. 4 billion miles away. We're small. Now, Mars. And I asked my young friend at the front if he could spot any Martians while we're here. Mars, the red planet, it's named for the Roman god of war. Before the space age, Mars was subject of many myths. There was a belief for a long time there were canals on Mars. People thought they could see all these lines there and started imagining Martians like this. And of course, Mars became a object of fear in many ways. People were afraid of Martian invasions. But in fact, that's what Mars looked like. These are the first close-up pictures of Mars back from 1965. Again, an illustration of memory. Putting this presentation together, I thought to myself, did I see those coming in live on TV? And I was convinced I must have seen them coming in live on TV. I went and researched it. Each image took 10 hours to transmit. I didn't see it coming in live on TV. I do remember being very, very disappointed when the first pictures came in. There were no canals, just craters like the moon. And now we know on the surface it looks like this. But look how far we come in 50 years from those very fuzzy pictures where a spacecraft, it was an impactor, it was flying straight into the planet and crashed on the planet. Now we're rolling around on the moon, on Mars. Fourth planet from the sun, cold, dry and dusty, very thin atmosphere, not very warm, low pressure. Its day is about the same as our day, and its year lasts twice as long as our year. Now you see, well, Earth's orbit is pretty almost circular, and Mars is a much more uneven orbit. So much so, that see from there, sometimes you're watching Mars over a period of days. It seems to reverse direction of the sky and move back forward again, called retrograde motion. Now back in the days when people believed the Earth was the centre of the universe, it was very hard to explain. Because if the Earth is the centre of the universe, and everything's going around the Earth, how can something go backwards? It's only when they realize the Earth is not the centre, even of the solar system, the sun is the centre of the solar system, they figure out what was going on. If you look on the left-hand side, you see how it appears to go backwards in the sky for a while and go forwards. The diagram on the right shows you what's really going on. It's just the angle we're seeing it from Earth as Earth goes round as well. Mars has two small moons, Deimos and Phobos. We always say potato-shaped. What's the shape of a potato? But they're small lumpy things, they're not round. They're too small to have become circular. And one of them, Phobos, is so close to Mars that in only 30 or 50 million years it's going to crash into Mars and break up. Again, like Earth, Mars is layered with a very, very dense core. And the reason Mars looks red to us is because of the iron in the surface oxidizing, rusting. So Mars is rusty red because Mars is covered in rusty red dust. It's not a breathable atmosphere to us, carbon dioxide, nitrogen and argon. The sky would appear red to our eyes because of the dust in the sky, red dust in the sky. But sometimes on Mars' surface, these storms build up with huge winds that create planet-wide dust storms, which can be very frustrating to astronomers because that's what you get. On your left is Mars as it would appear in clear Martian weather. On the right is a planet-wide dust storm, which covers everything for a while. And because the atmosphere is so thin, it doesn't protect Mars from stuff falling like meteorites and comets and things, so that's why Mars has all the craters. And those famous canals of Mars, they were a combination of optical effects and simple mistranslation. An Italian astronomer thought he saw channels, and he wrote he saw channels, but in Italian, channels is written canales. People in English-speaking countries read canales and translated it as canals. And that's how we got the canals of Mars. That's what Mars really looks like. Not so much like that. pretty strong evidence that there has been water on Mars in the past. Lots of the land structures show evidence of water flows, of deltas, of dry riverbeds. Water, of course, being a primary ingredient of life. It has the largest, Mars is the largest volcano in the solar system. It's called Olympus Mons. It would cover the whole state of Arizona. It's got the longest valley. It would cover the whole US. And because the atmosphere is thin, you could actually find your feet are warm and your head is cold on Mars if you daft enough to take your spacesuit off. This is a very recent picture. I don't know if you can see these small marks, the leopard spots. They match fossilized bacteria on Earth. So it's a strong hint that this would be fossilized bacteria on Mars. Bacteria is a form of life. So, life on Mars? What do you think? When I put this up, I realised that only a few of us are old enough to remember Disney's Martian. Any questions?
So if Mars's moon is going to go into Mars essentially, would that mean that it would sort of have a ring similar to like?
If depends whether it falls and impacts, you might end up with another moon coming off, as the moon was formed on Earth, an impactor threw something off. If it breaks up before it hits the surface, then you'd have another ring. You'd have a Martian ring. Hadn't thought of that.
Also, if isn't the like other than Earth, aren't the other isn't there like a moon that it has geological activity too and water on it?
Say again?
Isn't there like a moon that has like water on it too? Would that like how in terms of like for life does it have to be like?
I'll cover those more later in the outer planets. But two of the moons of the outer planets we believe, have subsurface oceans. Whether they get any heat is a different question. Good. But I'll cover, yeah.
I'm pretty sure Phobos and Deimos are like the sons of Mars in Roman mythology.
Very probably. I'll have to look at my mythology book, but there's they made lots of links when they named the first astronomical objects.
Also looked it up. It's not a question, but to answer his question, Venus has 80% of it is volcanoes.
Oh, you hear that? Venus is 80% volcanoes. 80% of the surface is volcanoes. So you're right. So like most volcanoes. Any more questions?
Yeah, where did the oxygen for the redness come from in Mars, and where did the water go to?
The oxygen to create the oxidation. Well, it had water originally. Water includes the oxygen.
Yeah.
Where the water went to, probably just boiled off. The Martian atmosphere pressure is very, very low, and it doesn't have the magnetic. It doesn't have the magnetic field that Earth has to protect it from the solar wind.
But the molecules must be similar.
See?
The molecules must be similar.
One of the theories is that Mars at one point had a molten core like Earth's, and that would have given it a stronger magnetic field similar to Earth's. As that molten core solidified, it lost the magnetic field. So now Mars is being pelted by the solar wind, and the solar wind is stripping away all the atmosphere.
Tore off the atmosphere and let all the water out. But the solid particles would have remained. And I do recall when the first Viking landers landed on Mars in '76, the first picture showed it with a blue sky, until they recalibrated the cameras and realized it was actually a red sky. Yeah.
When you said like the third requirement for being a planet is to like have like clear its like neighborhood, like does that mean it just like has to sort of like if it like it fits in the Kuiper belt, it just it's like moves away from it? Like how would you define like?
So I'm not catching that.
Like when you said that one of the requirements for being a planet is to like
to clear the neighborhood, right?
Like what?
Well, I'll ask Bill to come in on this one.
Well, I have have very strong opinions. That definition of a planet was made up by a small minority of astronomers, and when you apply it to places like Jupiter, Jupiter has not cleared out its orbit. There are 10,000 objects in Jupiter's orbit. So if you actually apply the definition of a planet to Jupiter, you have to disqualify it.
That's exactly what I was wondering.
Yes, it's a very nebulous and very controversial subject, and for us old timers, Pluto is still a planet.
It's also like if you were to find any sort of planet within the Kuiper belt, then
Well, they have.
automatically immediately.
Well, they have. And
like,
that's what led.
eliminate it.
That's what led to Pluto being demoted.
Yeah.
Because go back a bit. When they found Uranus back in the 19th century, and then tracked its orbit, they found its orbit was wobbling a bit. So they thought there's something else out there affecting its orbit, and they calculated and they looked in the right direction and found Neptune. But the orbits were still being perturbed by something, so there's a planet X out there somewhere, and they looked where that planet X was, and they found Pluto. In 1930? 1930? We found the ninth planet, Pluto. But then as time went on, they found more little planets out in the Kuiper Belt, like Ceres. So, hang on, Pluto's not the only one out there. So either we have lots of planets, or we limit the number of planets, and as Bill says, he made a decision to reclassify Pluto as a dwarf planet.
Which makes no sense because if you're going to make it like a spherical object, is one of the requirements to clear its neighborhood by far.
Think of clearing its neighborhood as clearing its part of the accretion disk. If you think of a planet formation as like just a large disk of.
We'll go to white light, please. Bill. Watch your eyes.
And if its accretion disk is its orbit around the sun, and if it's cleared that area, that might qualify. But if there's other objects out there within Pluto's orbit or within where Pluto's accretion disk would be, that may be part of it. Not sure.
Not sure we're getting a bit technical here, but Jupiter has the asteroids in front and asteroids behind, called the Trojans. So it hasn't cleared its orbit. So it doesn't quite qualify. So if you follow the legal definition of a planet, Jupiter's not a planet.
Maybe it just came down to the astronomers didn't want to count planets above the number 10. But no, there are dozens of small planets or planetoids out past Pluto. The discovery of Eris and realizing it was roughly the same size as Pluto kind of triggered this recategorization.
But I will be aiming in AstroFun 105 to cover stuff like the Kuiper Belt, the other solar system objects, including Pluto and Ceres and so on. Another question?
Does Earth has 5% volcanoes?
Earth has a lot more than 5 volcanoes. I don't know how many.
What percent volcanoes?
5% volcanoes? I don't know. Perhaps we should ask one of our experts. You're asking questions. You're good. He's asking questions we can't answer. We have to go look them up now.
I feel like most are underwater.
He's got an excellent shirt, by the way. But that's a very good point. Some of our volcanoes are underwater.
I knew that.
Yeah.
So Mercury, the smallest, closest one, has really, really hot temperatures and really, really cold
Yeah.
temperatures. So somewhere in there would be moving bands of like 0 to 100 degrees Fahrenheit, that livable temperatures. Is anybody looking at, get all the RV people to, just move along?
I feel like it's just not worth it to follow the bands.
Oh, I should just ask you at home. Do you have an opinion?
If you'd asked me that question 50 years ago, I would have said that Mercury had one face pointing at the sun all the time, one face pointing away. So this side was always incredibly hot, that side was always incredibly cold,
So
and
there
there'd be
would be
a moderate band
Right.
around it. But they somehow we found out it actually rotates. So it's
How
always.
fast does the temperate band rotate, though?
We get this
Slowly?
right. It goes round twice for every 3 times the planet orbits the sun.
Well, also with no atmosphere, there's nothing to transfer the heat
Yeah.
from one to the other. So it's literally like in the shadow, it's minus 200, and in the sunlight, it's plus 400 or 800, whatever. So like, there's really
So-
no
But
band.
there would be
there's
some
nothing to conduct
dust
the heat.
zone.
What even?
It could be like anything that vaporizes on the surface would conduct heat reasonably.
But
Very small.
it's
Yeah.
always
Very
turning.
quick change.
It's always turning. So
Yeah.
the side coming towards the sun is going from incredibly hot to incredibly cold, and
Yeah.
vice versa on the other side. But wasn't there some science fiction author wrote a series of books called Ringworld? I think the theory was you had a planet that was always on one side facing the sun and had an atmosphere, and one side is incredibly hot, and the other side is incredibly cold, and people only lived in the band around it.
Yeah. And it's called Ringworld.
Yeah.
Okay, Larry Niven.
Terry Pratchett, I think it was.
That was Larry Niven.
Terry Pratchett did Discworld.
You might find some interesting places where the temperature might be moderate near the poles, where you don't have direct sunlight. So there could be places, just like on our moon, that there's
Right.
places that never see the sun, and there's places that always see the sun. So
Or like on Earth, places that never see the night sky, like New Milford.
my second Saturday.
Good night, guy.
Oh, these are good questions. Thank you. Any more? Thank you.
I feel like without an atmosphere, everything would just either get blown off or the sun would destroy it.
You both got great. I've just realised you both have great shirts.
There's no atmosphere to capture the sunlight as it vaporizes. It's like
I mean, it's like on Earth when it's like an atmosphere and we're far from the sun. Well, Mercury is none, and they're not so far from the sun, and we're already getting sunburnt and stuff. I feel like that would probably not work out so well.